everyone, and welcome to our yet another discussion on Unit 3, which gives us a full discussion on classification and presentation of data. The previous time we met, we talked about the frequency distribution table, and of course, I was focusing our discussion on Unit 3 of the handout that has been loaded onto your student account. We have looked at classification of data. We have looked at the importance of classifying data. We've had a discussion on qualitative and quantitative data classification. And of course, we've looked at the presentation of data, where we have tallied. We, of course, had a discussion on how to construct a frequency distribution table. I demonstrated in the previous lecture how to tally and how to come up with the frequencies. And of course, this one you have already done from your previous discussions, from your previous classes. You should have been able to do this, though we bring it back here just for recap purposes. And in that lecture, I of course mentioned that if you're given this kind of raw data, the one that we have on this is our page number 14. If you have this kind of data, then you can smartly present it in a frequency distribution table by grouping this data in some kind of classes, which we call the class limits. Again, we looked at some of the features of the frequency distribution table, like the class limits, of course. We talked about how to determine class boundaries. We talked about the class width. We talked about the class mark and all that. So the table on your page number 15, which is presented as figure 3.3, is ideally a fully completed frequency distribution table showing the different class limits, the class boundaries, the class marks, and the frequencies for the raw data that has been given on page number 14, this one here. Okay, so as you can see, the raw data is too much. When you look at this kind of data, is really too much. These are 100 students. These are marks scored by 100 students, and of course, when you talk about 100 people or a population of 100 people, that is something that is too much. So a frequency distribution table usually comes in to try and compress this data in some kind of grouping, which are the class limits, so that the users of this data can actually do some good interpretation and analysis. So basically, that was our discussion, and of course I mentioned that we would move into another discussion on the histogram. So basically, in this lecture, I just want to bring out our tool here, which is known as the histogram. Now, the histogram is examinable at the quantitative techniques level. The examiner definitely assumes the fact that the student has appreciated the construction and the importance of the histogram. Now, the histogram that we have on our page number 16, I'm focusing on this figure here, figure 3.1, has been constructed using the data that we have here in our table 3.3. Now, as you can see, the histogram has been constructed along two axes. You all know the x-axis, which is the horizontal axis, okay, and then we have our y-axis, which is the vertical axis right there. So basically, for you to construct a histogram, you need the x-axis, and on the x-axis we put the class marks. Okay, we put the class marks, and then on the y-axis we plot the frequencies. Now, there's something I need to mention about the x-axis or the horizontal axis. Now, if you don't use class marks, you can use the upper, okay, you can use the upper class boundaries. Now the upper class boundaries in most cases are going to be used if you really need to determine the mode. Okay, of course, from your previous discussions, you should have appreciated the fact that the histogram is used to determine the mode. Okay, if we want to determine the mode graphically, then the histogram is going to be the best tool that you're going to use to determine the mode. Now, if you don't want to determine the mode and you simply want to present data on a histogram, then it is okay. You can go ahead and use the class marks against the frequencies. But if your objective is to determine the mode, then you have to use the upper class boundaries, or any class, or we can even just simply say class boundaries. You can use the class boundaries vis-a-vis the frequency. Now, as you can see, the histogram, for exam purposes, your histogram should cover 3/4 of the graph paper. Okay, it should cover 3/4 of the graph paper. 3/4 would ideally mean that you will leave only 1 centimeter from the boundary vertically and another 1 centimeter from the axis horizontally. In that way, your graph is going to be 3/4 of the graph paper. It is a rule of the game. The the histogram must cover 3/4 of the graph paper. Why do they do it like this? Because we don't want to have a case where people present histograms that are too small. So that's the first thing you need to note. Then next, what you need to note is that it is always good to ensure that, if I just clean up this, it is always important to ensure that the scale that you use covers is reasonable enough. For example, as you can see, a horizontal scale on the x-axis, we are leaving some kind of if you try to measure, this is about 2 centimeters. These are about 2 centimeters. Okay, so you try to be as systematic as possible, and I would encourage you to ensure that you leave 2 boxes. If you this is what I would call a small box. That is one small box and another small box. So if you count these tiny boxes, there are actually 10 of them. Okay, that one is going to help you to do some kind of good approximation in case you want to read off some figures from the histogram. Then, as you can see on the y-axis, again we are leaving 2 centimeters. Okay, these are almost 2 centimeters. Okay, it would be very nice if your scale on the x-axis or on the horizontal axis is the same as the scale on the y-axis, or what I may call the vertical axis. So try to utilize the graph paper given to you as much as possible. The other feature is that the histogram may not necessarily begin from the origin. It may even start from here. So if it starts from away from the origin, then you need to indicate that you are starting from there. There is a sign that we use. Let me just put off this. There is a sign that we use, some kind of a zigzag sign like that. If your histogram does not begin from the origin, from 00 here, then you can make use of that sign and begin away from the origin. But for the case of the graph that you have in your notes, I began from the origin. Now, the other feature is that the graphs that make up the histogram actually touch each other. Okay, they are touching each other. There are no spaces. This is not a bar graph, so don't go to the exam and you begin leaving the way I'm demonstrating here. You begin leaving gaps between the bars. So that one is totally wrong. You shouldn't leave gaps between the bars. If you leave gaps between the bars, then it becomes a bar chart. Okay, it becomes a bar chart. But for the histogram, the bars are supposed to touch each other. They are supposed to be next to each other, just the way we have demonstrated on that page. So that is as simple as it can be. Of course, as I've mentioned, histograms have already been drawn from your earlier studies, especially if you were a candidate of senior 4, senior 6. If you had done mathematics senior 6, you could have done this. But of course, we all know we went through senior 4. So the mathematics of senior 4, at least, this is part of what you studied earlier. So we just bring it up to try and recap what you did earlier. Now, on the same page, I also demonstrate the construction of what you call the frequency polygon. The frequency polygon is again constructed, or it superimposes itself on the histogram. So what you do, you simply get the midpoint. Okay, you get the midpoint of each bar. You just get the midpoint, what you would say is the middle of the bar. Then you continue. It is just disturbing me here, but ideally, as you can see, let me just put off this. As you can see, we are concentrating more on that middle part. Okay, just that middle part there. As you can see what I'm doing, then after getting the midpoint of the bars, this is becoming a bit tricky for me, but as you can see, my cursor is the red points. I'm putting them just in the middle of the bar. So after getting the midpoints, then you join them. Okay, you join them to get a line that is connecting between those midpoints. So that line that you get, or the line that superimposes itself on the histogram, is ideally what we call the frequency polygon. Again, as I've mentioned, the frequency polygon is going to be part of those areas that are going to be examined. So ensure that before you go for the exam, you know how to construct a frequency polygon. Now, the other questions I usually get, candidates usually ask me, do I need to use a meter rule to construct a frequency polygon? Yes, you're supposed to use a meter rule to connect between those points that are being made, or the midpoints on the bars. So for now, that is what I can mention about the histogram and the frequency polygon. What I've mentioned is that the histogram is a plotting between the class mark or class boundaries versus the frequencies, which are plotted on the y-axis. At the same time, I've mentioned that the histogram is basically an illustration of connecting bars. You're not supposed to put spaces between the bars. The bars should touch themselves, should be connecting. And then the other thing I've mentioned, that don't leave spaces. If you leave spaces, then ceases to be a histogram, it becomes a bar chart. Then again, maybe what I've forgotten is the shading. Do not shade the histogram. People have a tendency of shading them. Please do not shade this kind of thing. This kind of thing is not allowed. Let me just try to put this one out. Now what I'm saying is that you shouldn't shade. Okay, you shouldn't shade the histogram. That kind of shading, members, please, 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 as you're going to the examination, do not shade. Okay, do not shade. No shading. I hope I'm making this point very, very clear. Please do not shade your histogram. If you shade the histogram, it ceases to be a histogram, to become something else. So these are the things I want you to note. And of course, don't forget, as I've mentioned, to construct a frequency polygon. The frequency polygon will superimpose itself on the histogram, and you simply get it by connecting. You just plot the midpoints of the bars of the histogram, and then you connect those dotted points or plotted points using a meter rule to get a very, very smooth line, and that smooth line is what forms to be our frequency polygon. So in the next video, I'm going to talk about the cumulative frequency distribution. The cumulative frequency distribution is basically what we call the ogive, and we are going to see the purpose of the ogive and how to compute and determine the OGIF. So for now, I leave you to go and practice on how to draw the histogram. So what I want you to do is to try out, because we have already done 2.2, we have drawn the frequency distribution table. So what I want you to do is to draw for me the histogram for question 2.2, and then for question 2.3 I want you to do everything. Get for me the frequency distribution table, then you get for me the histogram for that data. What you do, just take a picture and send on my WhatsApp number, which is on your screens right now, so that I'm very, very sure that you have managed to capture whatever we have discussed. And of course, don't forget, if you have any question, just drop it in the comment section of your account, of your online account. So for now, I leave you to go and do those two questions, and then after that, just go straight to the video that discusses the cumulative frequency distribution.